today is to figure out whether or not our critical point is an actual location of a max or a min. Put your phones away. Now, remember from last unit how we discovered, perhaps rediscovered, slopes equal rates of change of functions. Secant slope. That's a secant slope right there. It's equal to 1/3 from A to B. Well, that tells me the translation of this is, on average, my function, whatever it is going up 1/3 of a y per x over my interval. Great, average rate of change. Now, when we look at a slope of a tangent, we would say at a specific location, I know exactly how quickly my function is going up. I'm going up 3 y's per x. I threw in another one down here. At C, why did I say 3? Sorry, at x equals, this is B. At x equals C, my function is going down 2 y's per x. Now, what's important is that I can replace this with anything. This could be f, and I'd say f is going up, f is going up, f is going down. But it doesn't have to be f. I could say this is f prime, which means f prime's going up, f prime's going up, f prime's going up. So just slopes of tangents. Doesn't matter what we have, but let's just start with f. Now, I used up and down. How do I know that we're going up? How do I know that we're going down? Discuss. Positive versus a negative. And this is important. This is like the key to this lesson and the key to our discovery of whether or not critical points are actual maxes or mins. Because what we know, but just to kind of put it home with emphasis, if my tangent slopes are positive, I'm going to go ahead and just put pluses here. I'm going to put pluses here, even though I'm thinking about sketching tangent slopes. If my tangent slopes are positive, my function is going up. It's going up. It's increasing. Now, what's very important about this concept of going up is that we are looking at things from left to right. We're in America. In America, we read things left to right. All right? We don't go up or down or right to left like other countries do. We go left to right. So that's very important. Left to right, going up. When my slopes are negative, I'm going down from left to right. I'd say I'm decreasing in my values. Positive values becoming less positive in terms of the values. Negative values becoming more negative. That's decreasing in the values. When my tangent slopes are 0, I am neither going up nor going down. I have flattened out. Or I'm constant. Okay? And the key to discovering if critical points are going to be locations of maxes or mins is this concept. That something is increasing, something is going up if its derivative is positive. Something is decreasing if its derivative is negative. Something is constant if its derivative equals 0. Now notice I did not say f. F is increasing if f prime is positive. That's true. I don't start with f because I want us to be ready to be talking about other things besides f. I might give you a function v. Well, you're going to look at v prime. I might give you f prime and ask you when is f prime's values increasing. You would look at f double prime. After lunch, we will figure out if our critical points are maxes and mins. I'm going to repeat this. Why we need to know this is that this knowledge will help us determine if critical points will be maxes or mins. Okay? What we are going to do is we're going to pretend we can't like see this graph. You know, you don't have to like cross it out, but pretend you don't see it. But you have a critical point. And through an analysis of signs of derivatives, like the sign of f prime, if I know f prime has negative values, I know my function is going down. If I know f prime has positive values, I know my function is going up. Well, if we are able to produce something like this, we will know the shape of my function must look like this, provided that at this critical point C we have a 0, which means we flatten out. Well, at the critical point C, we might have an undefined value. We shouldn't be afraid of that. It could be a situation where we have a sharp point. It's still a min. Okay, that's a possibility. But there's also other possibilities if we have undefined, like if I have some undefined value, maybe I actually don't have a function value and I actually like decrease and increase, maybe something like that. It wouldn't look like that, but don't worry so much about this. Instead, just understand that our goal is to be able to produce this to know that f is going to look like this. And once I know that, I know this is a min at x coordinate location. So pretending that I don't see this graph, or this graph, or this graph. We're just pretending here. If I'm able to produce a sign analysis of my derivatives of this function, and I know that f prime values are positives through a 0 then negative, then I know f has to be going up and down. I will know that my function has to look like this, and this is a max. Now, if there's ever a situation where we like go up, then continue to go up, this critical point's not going to be a max or min. We have situations where we might have positive values, then a 0, then positive values. That's not crazy. That's not unheard of. Well, we will find that, yeah, we won't have a min or max. We'll have just a flat point like that. Okay, and the same thing goes for there. So this is what I'd consider like a neither. All right. But this is the extra step that we are doing today that will help us determine if our critical points are maxes and mins. Okay? So, understanding signs of derivatives, whether things are positive or negative. Well, the question then becomes like, how do I know when things are positive or when things are negative? What separates positive from negative values? And this is kind of a reasoning why critical points are so critical. What did you say, Mr. Core? Zeros. It's perfect. Here's some function. here are positive values on my function right here. Here are negative values on my function, right? If we think about things being positive as above the x-axis, negative is below. What separates positive from negative values? Zeros. What's another situation that I could have where I go from positive values to negative values, but I'm not separating by zeros? An asymptote. Very good. DeSantis, if I had an asymptote, I could go from positive values to negative values. What is going on at this asymptote? I have an undefined value. What would be a third situation? It's also an undefined situation. A jump. On fire today. Man, usually I pray that I get an answer from students after lunch to questions. Okay? A jump. We separate positive values and negative values. This is why critical points, or when we were trying to find when a derivative is 0 or undefined. Okay? Because we will find that this is where f prime might change signs, and when f prime changes sign, I'll have a min or a max. Okay, cool. So let's start doing some of this sign analysis. Now, I'm going to preface this question. So I'm going to write some more. I'm going to say, hey, before you get here, the question really is, if f of x is 1/3 x cubed minus 4x squared plus 7x. Go ahead and write that down. I'm going to ask the question, when is f of x decreasing? Don't take up all the space, though. We're going to need some space. So write it next to the question that you have, because I can give you some space. Okay? If f of x equals 1/3 x cubed minus 4x squared plus 7x, when is f of x decreasing? Looking at your notes, discussing the neighbors, how do we tell if something is going down or decreasing? What is less than 0?
The derivative.
There. Okay. So you are going to be looking for when this function's derivative is negative. All right, well, I took the derivative. The derivative of 1/3 x cubed minus 4x squared plus 7x is this. I want to see when this is negative, okay? So kind of like I just had a step to get to where our question was. Cool? Now, how do I figure out when things are negative? Like I said before, zeros or undefined values are important. The reason why we're finding critical points, because zeros or undefined values are important. Because if I know where my zeros are located, I know that inside or outside, all of my signs are going to be the same. So if I know where my zeros are, I'll be able to figure out where my negative values are. So a lot of people like to think, I don't know, start plugging in some x values. No. Let's find zeros and undefined function values. Let's find those critical points that we were finding last class. So we are going to take this and we are going to set it equal to 0. Okay, we're going to factor. Also, we're going to see when we have undefined, but we don't have to worry about that because there's no denominator, right? Right. And we get 2 zeros, 1 and 7. Great. Now what I'm going to do is try to create something like this. I'm going to throw down my zeros on a number line. And I'm going to analyze the signs of f prime, knowing that I have zeros at 1 and 7. I know that I'm going to have either positives or negatives everywhere between 1 and 7. I know I'm going to have positives or negatives everywhere after 7. I'm going to have positives or negatives everywhere before 1. After determining whether we have positives or negatives, we will then be able to determine the behavior of f. I'm going to put it down here. I'm either going up or down. Either going up or down. Either going up or down. Okay? Okay. Before we start doing the sign analysis, how am I so sure that all of my values between 1 and 7 are all positive or all negative? Why can't I say I have some positives here and then some negatives here? Discuss that with your neighbors. You're on top of it. You're smart. There would be another 0. And if there was another 0, I would have found it already. I have found all the zeros. I have exhausted all of my potential sign changes. Okay? So I know for certain it's either positives or negatives. Now here's what I'm going to do. I'm going to, understanding that, pick a test point, some value inside my interval. I'm going to write it small, but it's going to be like 3 or 8 or 0. Because I found all of my zeros and all my undefined values, if all the zeros are found, or all the undefineds are found, if I know the sign of something at one point, I'll know the sign of everything on the interval. If I know the sign of one value in an interval, I'll know the signs of all the values. Okay? Okay. So, we will just need to figure out what is the sign of f prime at 3 or at 8. Well, we could take 3 and 8, we could plug it into f prime. But we actually have multiple versions of f prime. This right here is a version of f prime. I've already simplified it, I've already factored it. I'm version, this factored form, because it's easy for me, if I know products, to understand signs of products, right? I know a positive times a positive is a positive. I know a positive times a negative is a negative. I know a negative times a negative is a positive. Well, watch. If I take 3 and plug it in here for x, 3 minus 1 is a positive value. 3 minus 7 is a negative value. I don't care what the values are. I don't care what the numerical value is. I just care that at 3 it's a negative, which means all of my values are negative. Which means my function f of x has to be going down from 1 to 7. I've just answered my question, but maybe there's more locations where I'm going down. Let's see. I plug in 8. You can do it. 8 minus 1, positive. 8 minus 7, positive. Positive, which means I know my function f must be going up. 0. 0 minus 1, negative. 0 minus 7, negative. Well, that's a positive. A negative times a negative. It means I know my function is going up. Knowing that my function is going up, then down, then up, I know f is decreasing between 1 and 7. I know x equals 1 is a max. I know x equals 7 is a min. We now can take our critical points, do some analysis, and discover if they are actually, in fact, locations of maxes or mins. Watch this. I can graph 1/3 x cubed minus 4x squared plus 7x, and I will show you that you are 100% correct in your analysis. One-third x cubed minus 4x squared plus 7x. Oh, look, there's my max. Where's that max located? At 1. My function is going down between 1 and until I get to 7. I see 7's at negative 32 and 2/3. Let's go ahead and just pop down to negative 35 so I can see it. I'm going down until x equals 7, and then I'm coming back up. Here's where my function is going down. It's when its derivatives are negative. Here are my zeros, my zero derivatives. I've done that analysis just by looking at the signs of derivatives. Okay? Okay. Next one. I'm going to preface this one. Let's say you've already taken a derivative and you got x squared minus x minus 6. Let's go ahead and multiply everything by 3. So this is negative 3x squared plus 3x plus 18. Okay, let's say I said, hey, if f of x is negative x cubed plus 3/2 x squared plus 18x. Let's say I gave you that function. And I said, hey, looking at this function, what are the critical points and are they maxes or mins? Well, this is what you would do, and I've already done it for you. You would take the derivative, you would set it equal to 0, see when it's undefined, you would factor to solve. We have this factored form, don't forget about this negative 3. Negative 3, x minus 3 times x plus 2, you would take that and set it equal to 0 or see when it's undefined to find the locations of the critical points for f. Do you understand? Like, I don't want you to be confused with me just starting out with f prime. Pretend you have f. I'm asking you about critical points and maxes and mins. You would take the derivative. You would then factor. Cool? Okay, great. Well, you know the critical points are at negative 2 and 3. Tell me, are those critical points maxes or mins. Go. Don't forget about this -3 in front of things. If I'm able to determine the signs of f prime, I will be able to tell if -2 or 3 are maxes or mins. My advice is to start actually all the way over to the right, because it's usually when I have like positive values. So like 6, I'd have -3 times a positive times a positive. I don't care about the value. I do care that I have a negative. Okay? Do the other 2 intervals if you haven't done so already. Understanding that at -2 and at 3, we have zeros, which means we flattened out. Take any value in between -2 and 3, like 0. -3 times -3 times +2. Positive. Pick any value like, I don't know, -3, -4, -5. Negative, 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 negative. Because I know the signs of f prime, I know whether f is going up or going down. I know that -2 is going to be the location of a min on f, and I know 3 is the location of a max on f. Don't believe me? You can graph this, and you would see that. Okay? For the next one, now, for the 2 sign analysis examples we've done, we've noticed it's like negative, positive, negative. You know, they kind of flip-flop, positive, negative, positive. A lot of you may think, and you all try to be smart, that the signs are just going to alternate, and you just find one sign, and then you just blindly go bloop, 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 bloop. But that's not going to be the case. Now, let's pretend that I gave you a function, f of x. And let's pretend I asked you, what are the locations of the relative extrema for f, for this function? And you're like, cool. Let me find the zeros of the derivative and do a sign analysis of the derivative. So you then took the derivative, you found the derivative, it's equal to something, and then since you guys are masters at factoring, you factored your derivative to get you this. You guys stink at factoring, so I gave it to you. Okay? I did the legwork. You guys tell me, where are the maxes and the mins on f? Go. We'd first find the critical points, the important points where signs may change, the zeros or the undefineds, 2, 3, and 4. I got zeros, so I flatten out. at those locations. Let's analyze the signs of f prime. You will not alternate positive, negative, positive, negative, positive, negative. Do the sign analysis, check with your neighbor. Do you need another copy?
I was cleaning out my folder yesterday. I'll have my back on.
Keep the copy. Do the analysis, please. It is important to practice and knowing signs of things. Now, in the future, you will discover that if you see something squared, that affects things. It has to deal with multiplicities, stuff that you've learned in past math classes, but just by looking at this, I know that my signs are not going to change at x equals 3. So after doing your analysis, you should see the signs won't change at 3. So if you see them change, you're wrong. Ready? 5. 5 minus 2, positive. 5 minus 3 squared, positive. 5 minus 4 cubed, positive. Easy. 3.5, positive. Always positive. 3.5 minus 4 is a negative. A negative cubed retains its sign, negative. 2.5 minus 2 is a positive. 2.5 minus 3 is a negative, but I'm squaring it. It becomes a positive. 2.5 minus 4 is a negative. A negative cubed retains its sign. It's a negative. I didn't change sign. At 1, negative, positive, negative, positive. This is telling me F's behavior. F must be going up, then down, then down, then up. What? 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 Can that be? Yes. We are comfortable with seeing a critical point that is not an extrema. Here is the location of a horizontal tangent that is not a max or a min. That's what's going on at 3. I do have a max at 2. I do have a min at 4. I would say x equals 3 is a neither. Okay. All right. Now, I'm bored of doing all the work for you. You guys do some work now. This is a function. Please tell me where this function has maxes and mins. 1's the location of a max, 5's the location of a min. If we had a calculator, we graphed that, we would see that. It's pretty cool. Let's look at the next one. Go ahead. I'm going to go ahead and graph this for you guys, so when we're done we can see our work in all its beauty. Since I had 4x squared factor out, 0 is a critical point. Because I'm squaring things, 0 squared, or a negative value squared is a positive. Keep that in mind. If I plug in 2, positive times a positive, okay. If I plug in a half squared positive, sure. A half minus 1 is a negative. So positive times a negative, that's a negative. If I plugged in -1, I square it, that's a positive. -1 minus 1, that's a negative. So I have this situation here where f is going to go down, flatten out, go down, flatten out, go up. I know it flattens out because these are zeros. So it looks like this function only has a min at 1, and 0 is one of those neither locations where you go down, flatten out, go down. Like that. This is x to the 4th minus 4/3 x cubed. It goes down, flattens out at 0, gets to the point 0, 0. Goes down, gets to a min at x equals 1. If I plugged 1 into this function, you see the y-coordinate of the min, which would be the next step of what we would want to do, is to find like minimum values. I know this is going to be like an absolute min because I'm going down, then coming back up. It's not only going to be a relative min, I can look at this and say, oh, that's going to be the location of an absolute min. And then I can find the actual value by plugging 1 into my function. Okay? Cool. I'm going to come back and do this during Genius Hour. I want you to look at this one. And then we have another one to do. I told you, careful, tricky. All right. Please discuss with your neighbors. What part of this question is the reasoning behind why this is tricky? Nope. What was that? But it's what is increasing. So it's asking us when f prime is increasing. Now, if I gave you this problem without the careful, tricky part. And if you weren't reading carefully, this is what all of you would do. Maybe one or two of you would not. You would take the derivative, 3x squared plus 6x. You would factor. You'd set that equal to 0. You do 0, negative 2. You do your sign analysis, negative 2, 0, positives, negatives, positives. You're saying, okay, when we got positives right there, but you'd be wrong. Nope. Because these are the signs of f prime, which tell us if f is going up or going down. Oh, light bulbs? Okay, answer this question now. I don't want us to think that it is the second derivative. I want us to think that it is the derivative of what we're trying to find that's increasing. I want us to almost think that this is like f prime prime. It's the derivative of f prime. Is it f double prime? Sure. But it's derivative. So I'm going to leave it as like f prime prime. 6x plus 6, set this equal to 0. Negative 1. Here is f prime's prime, which is telling us what's going on with the behavior of f prime. I would not factor this. It's easy enough to plug in something like 0. 0 plus 6 is a positive. Negative 2 times 6 is negative 12 plus 6 is a negative. Because f prime's prime is negative, f prime is going down. Because f prime's prime is positive, f prime is going up. So, when x's are bigger than negative 1, f prime is going up. It's increasing. Okay. I will do the next example during Genius Hour, getting to these tricky problems, which make sure you understand this concept of signs of derivatives. Okay, ready? I'm giving you the graph of f prime, and I'm asking you questions about f. Could get better. The questions are about f. The questions are about f. I don't give you f. Hold on, this is important. If you said extrema, oh, x equals negative 1, that's a max. X equals 2, that's a min. You are wrong. Wrong. Why are you wrong? Here's the reasoning why. F prime has positive values here. F prime has negative values here. We can translate this two-dimensional graph into a one-dimensional sign analysis, determining that around negative 3, 1, and 3, f prime changes sign. This helps us determine that f is going down, then up, then down, then up. X equals negative 3 is the min on f. X equals 1 is the max on f. X equals 3 is a min on f.
So they're both min?
Yeah, I got two mins. You got to make sure you do your homework. Because f prime changes signs from negatives to positives. Listen, all I'm saying is that I got negative values. F is decreasing.
was again for showing up late to the second part of class. I didn't realize that the Letterman jackets were going to take so long to get done. And next day we could like do it. There's another day, but it's like
Totally fine.
during rehearsals. Thank you so much.
Don't worry about it. Critical points at -3, 1, and 3. Maxes, mins at those locations. Let's do another one. What are the critical points on F? Where are the maxes and mins on F? Okay, again, the question's about F, but I'm given F prime. Here are positive values of F prime. Here are negative values of F prime. Translating this from a two-dimensional graph to a one-dimensional sign analysis helps us determine that F, whose derivative looks like this, is going up, then down, then up, which means the critical points are 0 and 2. 0 is a max, 2 is a min. Be careful about the questioning. If it asks you for maxima, you're only looking for locations of maxes. When is F increasing? Something is increasing when its derivative is positive. All right, well, you can translate this into a sign chart, but you should be able to get to the point where you see positive values, negative values. When F prime changes from negative to positive, F is going down and up. This must be a location of a min, not a max. When F prime changes from positive to negative, F is going up then down. This point, this critical point, is the location of a max. Would 4 be the location of a max? Nope. F prime goes from negatives to positives, not a location of a max. When is it increasing? When F prime is positive, we are positive. Between -4 and -1, we are positive after 4. We can write that in multiple ways, either using set notation or interval notation. All right. Here's a situation where I got negative values here, positive values, I got a 0, but on positive values again. So it's like one of those situations with your sign analysis where you do change signs and you hit a 0, but you won't change signs here. So that's telling me F is going down, then up, flattening out, coming back up. I have 2 critical points. But only one extrema. Read the question carefully. When F prime changes sign from negatives to positives, we will eventually be able to do this without looking at the sign analysis, without having to create one. It helps to be able to do it. And we see f is going down then up at -4. When is f increasing? When f prime is positive. That is from -4 to 3. Last one. I'm going to go back and do the other algebraic ones. I got to jump at 2. What does that make f prime of 2? Undefined. Beautiful. Do I have a critical point at x equals 2? Yes. Why? Remember, critical points, when signs could change, occur when our derivative is 0 or is undefined. Look, my signs change. Watch. Let's go ahead and do a sign analysis. This one's tricky. I got negative values, negative values, negative values. I got positive values, positive values. So, negatives until -1. Positives until 2. I have an undefined value. Then I got negatives until 3, positives until 5, negatives after 5. This is a 0, this is a 0, this is a 0. Does f have an extreme at 2? Yes, it's a max. How do I know that? Because this is f prime. F is going down, then up, then down, then up, then down. What would that look like? How can I have a max and an undefined tangent slope? Any ideas? The sharp point. Remember, you could have a function that goes down, goes up, sharp point goes down, goes up, goes down. That sharp point's a max. Its derivative is undefined. So, this jump freaks people out, but just do your analysis to determine -1's a min, 2's a max, 3's a min, 5's a max. I want us to be careful, though. I'll show you an example of if we change signs, how we won't have a max at an undefined value. So let's go back to this one where we had this quotient. Okay, going through kind of the same process, finding relative extrema. Doing all the legwork, but now got to remember the quotient rule. True to the top times the bottom, minus true to the bottom times the top. All over the bottom squared. X squared squared, x to the 4th. Remember, the key points are when this is 0 or undefined. Okay, when undefined is when the denominator equals 0. There's my first critical point at x equals 0. Second critical point when my numerator equals 0. I get 2x to the fifth minus 2x equals 0. Factor out of 2x, I get x to the fourth minus 1 equals 0. I'm just going to go ahead and immediately say, okay, 0, yep, that's important. I already had 0 here, so I get it again. And now with the x to the fourth minus 1, think of it like x squared minus 1, you're going to have a plus or minus 1. If I do the sign analysis, understanding we have a 0 here, but understanding that I'd have a denominator that equals a 0 here, okay, it's important to write those down. Now, keep in mind we do have a denominator. It actually doesn't matter for this situation, but for future ones, sometimes it would. This is my simplified f prime. And I took that, which was that simplified, put it right back there. Now, I could factor this more, but I find that it'd be more complicated than just plugging in values into these. So like if I plug in 2 times 2, positive, 2 to the fourth minus 1, positive, over. I already noticed that x to the fourth in my denominator, that's positive. Denominator is always positive, so positive here. If I plug in a half, you got to think about how 1/2 to the fourth power, what happens there? Turns into 1/16. If I take 1/16 and subtract 1, I know that is less than 0 because 1/16 is less than 1. So that's going to be a negative. I got a negative there. If I plug in negative a half, now 2 times negative a half, that's a negative. Same thing, negative a half to the fourth power is not negative 1/16, it's positive 1/16, minus 1, it's still negative. The denominator is still positive, this is a positive, and then at negative 2, negative times a positive, I'll have a negative. Through this analysis, I know f is going to be going down, going up, going down, going up. I would assume that x equals negative 1 is a min, 0 is a max, and I would assume that x equals 1 is a min. But this is wrong. It is not like a sharp point max. Why? Where? In f prime? Because I had that last graph where it was undefined at that x equals 1, but I still said it was a max. In f of x, if we go back and look at the original function, and I think about what's going on at f of 0, what's going on at f of 0? I have 1 divided by 0. What is that an indication of? A number divided by 0, a vertical asymptote. Very good, let's clean up. So actually, we don't have a point at 0. We have a vertical asymptote at 0. So this is not a max because there's no point whatsoever. If it was a sharp point, we would see a function value there. Really quickly, just so we feel good about ourselves. Watch. X to the fourth plus 1 divided by x squared. Minimum, negative 1. Minimum at 1, at 0, vertical asymptote. All through analysis of the sine derivatives. All right. We have one more example to do, which is the trig one. This is a cool one. And you need to practice this. Because in this, we will have to do a sine analysis by plugging in, radian measurements, which some people struggle to do. Same process holds. Take this, set it equal to 0 or C when it's undefined. I don't have to worry about that. I'll end up with cos x equaling a half. You need to know your unit circle to answer that question. Now I am going to throw down and do a sign analysis around pi over 3 and 5 pi over 3. Now, understanding my interval, I do have a starting and an ending point, which I haven't had until now. However, the next possible 0 would be at negative pi over 3, for the next possible solution. So though I have a starting point, it actually can be a test point in terms of the sign on my interval. And the same thing, I could actually go beyond 5 pi over 3 and get to 7 pi over 3. That would be the next solution there. So 2 pi, though it is my end, it also could be a test point. So I'm going to use 0 and 2 pi as test points. I will use them in what is my simplified derivative. It helps to use these extreme values like 0, like 2 pi, like a pi over 2, or like a pi. Let's see. 1/2 minus the cosine of 2 pi. Cosine of 2 pi, the same as cosine of 0, it's 1. 1/2 minus 1, negative. You can either think 1/2 minus cosine pi over 2, 1/2 minus 0. You could do 1/2 minus the cosine of pi as well. It'd be 1/2 minus negative 1. Either way, negative. Weird, we don't have a sign change at 5 pi over 3. Let's see. 0. 1/2 minus the cosine of 0. Cosine of 0 is 1. Oh, what am I doing here? This is a positive. 1/2 minus 0 is a positive. 1/2 minus negative 1, positive. I was thinking about another example on your homework where we don't have a sign change. Cosine of 0 is 1. 1/2 minus 1, negative. So I think, through this analysis, knowing that f is going to be going down on my interval, then up, then down, that this is the location of a min, and this is the location of a max. I'm going to graph this for fun to see that. 1/2 x minus sine x. Make sure your calculator's in radian mode if you're ever checking. So beautiful. At pi over 3, minimum. At 5 pi over 3, maximum. It's pretty cool how the graph looks with this 1/2 x attached to it. Yeah.
You want the test points, or is that just like a strategy?
Do I have to use 0 and do I have to use 2 pi as test points? Because I know it freaks some of us out because they are like endpoints of an interval. No, you could have used pi over 6. Anything between pi over 3 and negative pi over 3 would have worked. Don't go way over, understanding that there are an infinite amount of solutions to this equation. So either keep it between 0 and pi over 3, pi over 6. Keep it between 5 pi over 3 and 2 pi, 11 pi over 6. But it's actually easier to use 0 and 2 pi, knowing that the next solution is outside of that. Okay? And that's it.